Hi there. In this lesson, we're going to talk about confidence intervals. So we're going to do several things with confidence intervals. We're going to do the theoretical method and the simulated method, and we are sticking for right now with one proportion. Okay, so let's look at an example. This comes from a Pew Research poll, and the link is here. I'll show you the actual study in a moment. A Pew Research Center poll asked 1,453 U.S. teens aged 13 to 17 about their views on social media use. Of the teens surveyed, 668 said they supported requiring parental consent for minors to create a social media account. Create a 95% confidence interval for the true proportion of teens who support parental consent to create a social media account. Okay, so this is coming from this link, which you have in the course materials. There are a lot of these polls just going on all the time. You can explore this and find some topics you're interested in if you'd like to. So this headline is 81% of U.S. adults versus 46% of teens favor parental consent for minors to use social media. Okay, so there's a lot about social media and mental health right now. Okay, so you're welcome to explore this a little bit more. You'll see methodology, how we did this. And there's a separate survey for parents, a separate one for teens, and then you can even go more in depth. So I just picked one of the results. These are the adults. These are the teens, I think. Oh, here's the teen. Oh, these were young adults. These are the teens, so this is the 46% that I'm using. And if you scroll down even further, there's a little even more detailed methodology here. So if you're curious, you're welcome to look at that. It doesn't appear to be opening up right now. I was able to view it before, so not sure what's going on there, but you can check that out if you want to. Okay, so let's go ahead and do this problem. So we can use this to look at some vocabulary as well. So what is the point estimate? Point estimate is a general term because we could be looking at a proportion or a mean or a difference of proportions or difference of means. It's the statistic. It's another way of saying statistic. In this case, we have a proportion, and a sample proportion is p hat. And so we can get that by taking the 668 out of the 1453, and equals or approximately equal is fine. Either way works for me. 668 over 1453. We are going to have to round this, and you can see that's where they're getting the 46%, so 0.4597. Often their numbers are rounded, so it's not exactly 46, but it's pretty close, 0.4597. We're going to keep our 4 decimal places. Not because it's that accurate, but just to practice and make sure we're getting the right answers. Okay, so this is also called a sample statistic. Okay, and it is also the best estimate. Right, the best estimate we have is just to take what we got from the survey, divide by the total, and that is our sample proportion. Okay, now I don't know if you could see it in the methodology there. The most common confidence level is 95%. So we're going to stick with 95%. And that is the most common level. Okay, so keeping this situation in mind, let's look at the steps for creating a confidence interval, okay? And remember, the idea is we want to give not just the point estimate, because many people read that and think, oh, well, it's exactly 46%. But that's the result from one sample, right? And we know that there's sample-to-sample variation. So if we did a different sample of 1,453 teens and a different sample and a different sample, we wouldn't get the exact same number, 668. Likely would vary. So we have this plus or minus or margin of error to take into account that there's sample-to-sample variation, okay? So here are the steps. So, and this is called a z-estimate of a proportion. Okay, so first we've already done the first step. Calculate the point estimate, at least part of it. And then we also need to find the critical value z star for the confidence level. Okay, so we'll talk about that in a moment as well. Then we need to check the conditions. So if we're using a z star, if we're using the normal distribution in any way, we have to check the conditions to make sure we're going to have that normal shape, right? So check the conditions to use the central limit theorem. This pen might be dying. I think it is. I have a different one here. And those conditions are independence, randomization, large population, and success failure condition using p-hat. Okay, so you may have noticed when we did a hypothesis test, we used p0 because we were assuming the null was true. In a confidence interval, we don't have a null hypothesis. All we have is p-hat, so we're going to use p-hat. Okay, and then we're going to use this formula. Okay, p-hat plus or minus z star times, and you might recognize this as the standard error, square root of p-hat q-hat over n. Okay, so we're going out a certain number of standard errors, and we're going to do plus or minus that. Okay, then our next step is going to be writing the interpretation in context. We always want to write our context out. And then just a note, because there are multiple formulas within this one formula. Just like I pointed out, the square root part is the standard error. So you probably recognize that square root pq over n from talking about the sampling distribution. That's the standard error, and the width determines the width of our normal distribution. And then the margin of error, which is the plus or minus part. So it's the part that starts right after the plus or minus symbol. That is z star. So z star is going to be a certain number of standard errors that we go out to give us that middle, whatever, 95% or middle percent that we're looking for. Okay, so I'll show you a little bit more about how we get those numbers. Okay, so important to understand the square root part is the standard error. This whole plus or minus part is the margin of error. And then when we do the plus or minus, we get our lower and upper bounds, and that is our confidence interval. Okay, so in this video, let's go ahead and we've done our point estimate. Let's check our conditions, and then we will do the formula in the next video. Okay, so let's check our conditions here. Move this up. Okay, so the first one is independence. Okay, what do we need for independence? This is a survey of teens about social media use and whether they think they should have parental consent needed to get to have the social media account. Okay, so that's what they need to be independent of, right? Their views on parental consent on social media. So let's write that out first. The teens surveyed must be independent in their views about parental consent for social media. I'll put social media use. Okay, so that's what it means for them to be independent of each other in the variable that we're looking at. Okay, so we want to write down some things to consider, right? What are some factors that might influence this? so that when we take our random sample, we make sure that we don't have any bias anywhere, that we are getting a representative sample, okay? So some things that come to my mind are gender and maybe age within that age group. And then I'm always going to put race and ethnicity and income, those income, those are likely factors. And maybe urban versus rural. Maybe the type of school these teens go to. Right, so for example, we would not want to take our survey all from one school, right? Even if we did a random sample from one school, that could be representative of that school, but not representative of teens across the U.S., right? So this is what we want to be thinking about. Maybe possibly religion. Let's see if I had other thing. We also wouldn't probably survey multiple siblings from the same family, right? So different families. Whoops, etc. Okay, not that they would necessarily have the same view in the same family, but they've been in the same similar environment, right? Okay, so those are some things to think about. We just want to list some factors that we would want to consider as we get this random sample, okay? And then 2 is randomization, so it also has to be a random sample. We need a random sample. Okay, that one's nice. I like that one. Very easy. Number 3 is large population. Okay, I'm going on my list. That's right just above the top of the recording window here. Okay, so the population, and this is great because this is where we identify the population, right? The population of U.S. teens must be at least 10 times the sample size. So I'm going to go ahead and put the numbers in 10 times. Our sample size was 1,453. So that's 1453 with a 0 on the end. So 14,530 teens. Okay, I think that's safe to say in the United States. And the 4th one, success failure. Okay, this is where our n times p and n times q must both be greater than or equal to 10. Okay, remember success is the thing we're counting. If a failure is the thing we're not counting, the opposite result. And we only have a p hat, so we're going to do n times p hat, which is 1453, times our p hat up above, we divided, and we got 0.4597. N times q hat is 1453 times parentheses 1 minus 0.4597. Okay, so I'm going to do both of those. 1453 times 0.4597. Okay, 660, and it's okay to round these as long as it's over 10. 668, I'll do approximately 668, 1453 times 1 minus 0.4597 is about 785. Okay, so both clearly way over 10. Not a problem there. And because this is roughly in the middle, right, it's around 46, it's around 50%. So we don't need as big a sample size when it's in the middle as when our proportion is on one of the ends, okay? Okay, great. So practice writing out these conditions. You'll have a practice problem in this lesson, and we'll do the calculation in the next video. So I'll see you there.